Hey guys, Mr. Yaisley here. So we are on to lesson number 2, and we are working specifically with that process of finding the greatest common factors. Now in lesson number 2, we're only going to deal with numbers, all right? So we're just going to learn how to create those lists of numbers in order to find the greatest common factor. So in order to do that, the first thing I want to do is I want to start with the first number they give me. So on example A, they've given me two numbers, 24 and 48. So I'm going to start with that 24, and I'm going to figure out all the factor pairs. Now I think it's always in your advantage to go in order starting at 1. And the reason is once you finally hit a number that's already on your list, you know that your factor pair list is complete and you don't need to go any farther. So I always start with 1, and 1's always going to be 1 times whatever the number is, so 1 and 24. Then I got to think, does 2 go in? Well, 2 does go into 24, 2 times 12. Does 3 go into 24? 3 does go into 24, 3 times 8. Almost wrote that down wrong, sorry. Getting ahead of myself. And then I check the next number, 4. Does 4 go into 24? 4 does go into 24. 4 times 6. Then I check, does 5 go into 24? 5 does not go into 24. And then I want to check 6, but 6 is already on my list, so that means this is the complete factor pair list for 24. So again, if you go in order, it makes it a little bit easier for you. So then I need to do the same thing with the number 48. So I'm going to list out 48. Start with 1, and 48 is my first factor pair. Then I'm going to check, does 2 go into 48? Well, it ends in 8, so definitely. So 2 goes in 24 times. Does 3 go into 48? Well, if I add those two numbers together, 4 plus 8 is 12. 12 is divisible by 3, so it does. So 3 goes into 48 16 times. Does 4 go into 48? Yes, it does. 4 goes into 48 12 times. Does 5 go into 48? No, it does not. Does 6 go into 48? Yes, it does. 6 goes into 48 8 times, because 6 times 8 is 48. And then does 7 go into 48? No, it doesn't. And 8 is already on my list, so I know my factor pair list is complete. Now again, I've got 2 complete factor pair lists, but my goal is to find the GCF, right? So I'm going to start with my smaller number of the 2. So 24 is my smallest number, and I'm going to start with its biggest number, which is 24 itself. And I'm going to say is 24 in both lists. I see 24 here, and I see 24 there. So I'm going to circle them because that is my greatest common factor. So my GCF on example A is 24. All right, well, let's take a look at example B. So example B, we've got 3 numbers this time, 15, 24, and 36. So I want to start with my first number of 15. And I'm going to list out the factor pairs for that. So it starts with 1 and 15. Does 2 go into 15? No, it doesn't. Does 3 go into 15? Yes, it does. 3 times 5 equals 15. Now I need to check, does 4 go into 15? No, it doesn't. And 5's already on my list, so that's all the factor pairs of 15. So then I'm going to go on to 24. Well, we just did that one, so if you just want to copy over your factor pair list from the other one, you can. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then 36 here. Got to do that one. That's a new one, so I'm going to go through the list again. So 1 and 36. Does 2 go into 36? Yes, it does. 2 times 18. Does 3 go into 36? Yes, it does. 3 times 12. Does 4 go into 36? Yes, it does. 4 times 9. Does 5 go into 36? No, it doesn't. Does 6 go into 36? Yes, it does. 6 times 6. And I've hit the same number twice, and that's, again, if we're going in order, an immediate indicator to me that my list is complete when I hit that double number. All right, so now we've got our 3 complete list. So now I want to go back to my smallest number, which is 15 in this case, and start with the number 15 and see if it's on both lists. 15 is on our first list, of course, but it is not in the factors of 24. So that is not a greatest common factor. Then I'm going to check 5. Is 5 on both lists? Or on all 3 lists, excuse me. Well, 5's on the first one, of course, but it's not on the second one, so it has to be in all 3 lists to be a factor. So 3 is 3 in all 3 lists. 3 is here, 3 is here, and 3 is here. So 3 is the number that's in the greatest number that's in all 3 lists. So that means my GCF of these 3 numbers is 3. All right, well, I'd encourage you to try example C on your own, then check your answer with mine. So example C, we've got a list of 24, 60, and 96. They want us to find the greatest common factor. So I'm going to start by listing out the factors of 24. Again, we've done that one twice, so you can just copy them over. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Then I need to do my next number on my list, which is 60. So 60 is my number. Start with 1 and 60. Does 2 go into 60? Well, it ends in 0, so it definitely does. 2 times 30. Does 3 go into 60? Well, if I added the numbers together, 6 plus 0 is 6, and 6 is a multiple of 3, so yes, it does. So again, 3 goes in 20 times. 3 times 20 equals 60. Does 4 go in? Well, yes, 4 goes in as well. 4 times 15. Now, you may notice when you're making these lists, the numbers start really far apart, and as you go down the list, they start slowly getting closer together. So that's just an indicator that you're doing things correctly. So then 5. Does 5 go into 60? Yes, 5 does. 5 and 12. Does 6 go into 60? Yes, it does. 6 and 10. Does 7 go into 60? No, it doesn't. Does 8 go into 60? No, it doesn't. Does 9 go into 60? No, it doesn't. And 10 is on my list, so my factor pair list for 60 is complete. So then again, we need to do it for the number 96. So here we go, 96, listed out. 1 and 96. Does 2 go in? Well, it ends in an even number, so it does. 2 and 48. Does 3 go in? Well, 9 plus 6 is 15. 15 is a multiple of 3, so yes, it does. So 3 times 32. Does 4 go into this? Well, yes, it does. 4 times 24. Does 5 go into this? No, it does not. Does 6 go into the 96? Yes, it does. 6 times 16 equals 96. Does 7 go into 96? No, it doesn't. Does 8 go into 96? Yes, it does. 8 times 12. Does 9 go into 96? No, it doesn't. Does 10 go into 96? No, it doesn't. Does 11 go into 96? No, it doesn't. And 12 is already on the list. So now we've got the complete factor pair list of 96. So all 3 lists are made. So again, now we go back to our smallest number, which in this case is 24. Right? And I start with that number to see if it's on all 3 lists. So 24 is on the first one. It's also on the third one, but it's not on the second one for 60. So that means it is not a greatest common factor. It has to be in all 3 lists. So then I check my next one. 12. Is 12 in all 3 lists? 12 is in obviously the 24 list. It's also I see here in the 60 list. And it's also I see here in the 96 list. So 12 is the biggest number that goes into all 3 numbers. So it's the biggest factor. So we call that 12 is our greatest common factor. All right, well, I'd encourage you to try example D now on your own, then check your answer with mine. So again, got two numbers here, 30 and 45, so I'm going to check for greatest common factor by creating my factor pair list, starting with 30. So 30, that's a new one we haven't done before, so I need to create a whole new list. So 1 times 30, does 2 go in? Well, ends in 0, so yes, 2 times 15. Does 3 go in? Yes, it does, 3 times 10. Does 4 go in? No, it doesn't. Does 5? Yes, it does, 5 times 6, and 6 is already on my list, so my factor pairs are complete for 30. Then I do it for 45, so 45. 1 times 45, obviously our first one. Does 2 go into 45? No, it doesn't. Does 3 go into 45? Well, 4 plus 5 is 9, that's a multiple of 3, so yes it does, 3 times 15, all right. Then we check for 4, does 4 go into 45? No, it doesn't. Does 5 go into 45? Yes, it does. 5 times 9 is 45. Does 6 go into 45? No, it doesn't. Does 7 go into 45? No, it doesn't. Does 8 go into 45? No, it doesn't. 9 is already on my list, so my factor pair list for 45 is complete. So then again, back to my smallest number of the two, which is 30. Start with the number 30. Is it on both lists? No, it's not, so not a greatest common factor. Then on to 15, the next biggest number. Is 15 on both lists? Yes, it is. So 15 is my greatest common factor of 30 and 45. All right, well, if you have any additional questions on how to find these factor pair lists, please let me know. But this would be what you would show on your assignment to how you arrived at the greatest common factor. You'd list out the factor pair lists and use those lists to determine the greatest common factor. All right, well, you have what you need now to continue on to lesson number 3.